Okay, class, let's proceed to another topic in relation to our discussion with advanced data analytics. Today, let's proceed to introduction to structural equation modeling, or we call it the SEM. Okay. Now, I'd like you to know that we can actually connect exploratory factor analysis to. We're done with our discussion with exploratory factor analysis, but actually we can connect this analysis to structural equation modeling. I'll explain it to you later. No? So suppose you investigated what makes a person successful in your factor analysis. So you created questionnaire with statements. So that's the first thing to do in factor analysis. So suppose this is a questionnaire you have produced. Okay. So there are statements here, and we also have 1, 2, 3, 4, 5. Okay, your respondent will check 5 if they agree very well with the given statement. Okay, and 1 if do not agree. Okay, so that's it. So that's your questionnaire. And after you gather the data, you analyze the data using factor analysis, particularly exploratory factor analysis. And this is what you found out. You found two significant loadings. And these loadings are with three statements each, okay, coming from the questionnaire you created. So these significant loadings, you name them, the two significant loadings, you name them intelligence and bank savings, because the statement, I excel in academics, I have sharp memory, I can create ideas from concepts, are actually in line or related to the construct or the concept of intelligence. And the three statements here, I have personal bank account for savings, I love to save, and I have substantial savings, are actually statements that you can connect, or it's the statements that are associated with bank savings. And the rest of those statements, okay, which are not in red, are actually were not significantly loaded, okay, in a specific factor, okay. So you only have two factors, for instance, okay, out from this questionnaire. So you have created intelligence and bank savings. So I'll get back to you with these concepts later. I'll use these concepts as part of the example or illustration. Now, before we move forward to the discussion of structural equation modeling, or SEM, or SEM analysis, let's define first theory again. Okay, so it is a systematic set of relationships. Of course, we know that it provides a consistent and comprehensive explanation of a certain phenomenon or phenomena. Okay, and a model should not be developed because we'll be discussing later about the structural equation model and its modeling. So a model should not be developed without some underlying theory. Okay, take note of that. A model should not be developed without some underlying theory. You cannot just do structural equation modeling, connect significant concepts or constructs without um, without using a significant theory associated with the relationships you're trying to connect in a specific context. So I'll show you, or I'll show you some illustration on why it's important that we have to start with the theory. Suppose you have a theory that says intelligence leads to success. So take note that here, intelligence, okay, it affects, okay, success. Okay, so that's suppose there's a theory that says that intelligence leads to success. So try to take note of the figure. Okay, I don't write it in a square. I mean, intelligence is not inside a square box, but instead in a um circle, or yeah, if you can see it circle, but I don't know if it's a circle. Okay, but anyway, so it's not a box. Okay, intelligence, okay, affects or leads to success. Okay, that's according to the theory. So you want to find out if this theory actually applies in the context of someone's financial capability. Okay, so now you are applying this theory because this theory is very broad. So you want to contextualize the theory and you want to apply it in the context of finance. Okay, so it leads you to understand, or it leads you to create a model, or you want to know if this will work. Okay, you are proposing now a model. Okay, which of course you want to, you will have to test this model later by using by data gathering and by applying a specific statistical tool. Okay, but anyway, the point here is that you have these constructs here: intelligence and success. So you read the literature, for example, or you were able to read the literature, and then you found out that intelligence could be measured, okay, or could be measured using IQ score, because intelligence cannot be directly measured because it's a construct, it's an abstract concept. Okay, and even success, it's an abstract concept and very broad, very general. So you read the literature and you found that intelligence could be measured, okay, by using the variable IQ score. So now we are using the variable here. It's in in rectangle, okay, because it means that you can now measure it. Okay, so another is success. You found in the literature when you read, suppose that someone's success could be attributed to his or her, or I mean, someone's success in finance or in finances could be attributed to his or her amount of bank savings. Suppose, no, that's what you found in the literature. Okay, so therefore, you can now create a model which has a reflection to your theory. So that's what I told you, that you cannot just create a model without adhering to a certain theory. That's the point. So here you have now your proposed model, which says that IQ score influences one's amount of bank savings. This is what you would want to find out, okay, using data and even statistical analysis. And common statistical tool we use here is, of course, regression analysis. Okay, that's the common. And we already discussed regression analysis. Now, after we define the theory, okay, let's proceed to latent construct definition. So what is a latent construct? Other term the other term for latent construct is latent variable or latent variable. It's a hypothesized and unobserved concept that can be represented by observable or measurable variables. So in this case, we have here latent factor 1, factor 2, and factor 3, which can be measured by the observed variable. So what does it exactly mean? I mean, what does it mean? Okay, so let's go back to the example I gave you. Suppose you conducted an exploratory factor analysis and you found significant loadings, and you name these two loadings, groups of loadings, as intelligence and bank savings. So the the latent variables there are intelligence and bank savings. Okay, intelligence can be measured using these three variables here. We have I excel, the three statements. We have I excel in academics. I have sharp memory. I can create ideas from concept. Because basically, this you can really measure this by using the questionnaire. Remember, you have this questionnaire which you have indicated five numbers: one for do not agree and five for agree. Agree very much, or something like that. So it's two extreme numbers. So I excel in academics, I have sharp memory, I can create ideas from concepts. These are actually variables that could measure intelligence in this concept. And intelligence here is the latent construct or variable. Another latent construct or variable is the bank savings, which can be measured by using these three statements here. I have personal bank account for savings, I love to save, I have substantial savings. So we have a name of course, for this, or we have names for these latent constructs or variables. The one that affects bank savings, which is intelligence, is what we call exogenous latent construct or variable. Okay, these are variables that cannot be directly measured or observed, but it can be measured using observed variables, the statements. Okay, those statements in the box. Okay, another latent construct here is the back savings, and we call it endogenous latent construct or variable, the back savings, because it is it is what is being affected, okay, by intelligence, which is the exogenous latent construct or variable. So the back savings, which is another latent construct, and endogenous at that, okay. So we have three uh, way, or we can measure this with using these three statements. I have personal bank account for savings. I love to save. I have substantial savings. So this is what we call these are what we call observed variables, okay? So in linear regression, we call it independent variable. In structural equation modeling, we call it exogenous latent construct or variable. In linear regression, we call it dependent variable, but in structural equation modeling, we call it endogenous latent construct. So take note of that. Now, let's go back to the theory and the model associated with it. Look at this. Can you see I mean, you can see that the linear regression can be used here, okay, in our model, coming from, of course, with the theory, which says that intelligence leads to success as the basis, okay, for this model. You cannot just create a model without the theoretical basis. That's the point. So look at the figure. IQ score is in the box and amount of bank savings is in the box because these are actually variables that can directly be measured. Okay, but in the case of latent construct here, in this case, the intelligence is in not in a box because these are still constructs. Okay, but then the good point about structural equation modeling is you can actually directly link, okay, or create relationship or test relationships between constructs, provided that the constructs have associated variables which can be measured. Okay, so in this case, intelligence have three variables or the three statements in the box that we can measure. Okay, so these are actually the the concepts or even the variables in the construct that you created when you conducted the exploratory factor analysis. So exploratory factor analysis will just stop in, understanding the constructs and the associated variables that we can use to measure them. Okay, you will just stop there in exploratory factor analysis. But in structural equation modeling, you can actually create relationship between these constructs you have gathered by adhering to a certain theory or by having theory as important basis, okay, for creating relationship between those constructs you have generated from your exploratory factor analysis, because your exploratory factor analysis will not tell you, okay, what's the structure of relationships between those constructs you have discovered. You will just stop there, okay, finding for the constructs and the associated variables that we can use to measure those constructs, okay? That's where you just have to end in your exploratory factor analysis. But as to how we determine the relationship between those constructs you have developed or you discovered, you cannot do so in your exploratory factor analysis. But with the help of theory, okay, it can help you create a meaningful connection between those constructs. That's why I told you earlier that you cannot just create a model without theoretical basis. So if you have now your model, okay, you can use structural equation modeling because you cannot actually directly link, okay, two constructs, okay, two constructs in linear regression, because linear regression requires, actual numbers for each variable. But in this case, our variable is intelligence and bank savings, but these two are still construct. They cannot be measured without this, statements, those in the box. Okay, so this is the beauty of structural equation modeling as compared to linear regression, because you can make connection between variables even if the variables are in construct form, for as long as these constructs, the latent constructs, okay, the exogenous and the endogenous, for example, in this case, have corresponding measures, okay, uh, have corresponding measures, okay, that we can use to actually come up with a number for each of them. Okay, so that's the beauty of structural equation modeling. So another is in my study, I published this one, Truth Behind Economic Performance, Natural Resources, and Attracting Foreign Direct Investment. I did not use actually measurable variables for uh, each variable, because readiness, like for example, the variables I use here are not actually exogenous constructs and endogenous constructs. Okay, they can actually be measured right away. Okay, using certain measurement, but we cannot do this one in a simple regression analysis, or even in multiple regression analysis. We cannot do this one simultaneously, but in structural equation modeling, it can simultaneously do, okay, series of regression analysis. So that's why I use this one. This is actually just an exploration of structural equation modeling. Okay, aside from this concept. Okay, because this is the original concept actually for structural equation modeling. But yeah, I just wanted to uh, do simultaneous analysis, okay, that the linear regression cannot do. Okay, so that's why I use structural equation modeling. So that's why you might wonder, okay, why these are already in rectangle and not in the one that I gave you, the intelligence and the bank savings, because this was just quite an exploration, okay, of but actually it works. So yeah, so I think you can do this one as well. No, instead of using multiple linear regression analysis, you can do also you can explore structural equation modeling. Aside from this is the original concept actually, but you can also do this one. Okay. So what are the assumptions of structural equation modeling? So as usual, of course, we have this multivariate normality. The same with the other statistical tools I've mentioned. Okay. It also has the assumption of multivariate and normality. No systematic missing data, that's important. Okay. And sufficiently large sample size. And there must be correct model specification. Yes, that's important. That's why I told you earlier that you really have to have a wonderful theory to support your model before you create a model. So the point of, structural equation modeling actually is to, to expand a certain theory. Okay, applying a certain theory, to expand the application of a theory. Remember what I gave you earlier? There was a theory, and then suppose a researcher wants to know if the theory applies in the context of finances. Okay, so you have to contextualize the theory, because that's the only way we can expand the theory. You have to apply it in other contexts if it may apply, or you want to know if it applies in a certain context. Okay, that's the beauty of structural equation modeling, because it helps you expand the theory. So that's why it's important that you have this correct model specification based on the theory with a theoretical foundation. Now, in interpretation of you know structural equation modeling, so you have here you have to interpret the model fit. Okay, how good is the model? Even regression weight. Okay, you want to know the exact values. Okay, if how much, okay, a certain variable affects the other variable. Okay, so that's the point there of regression weight. And we also have this path analysis here, the mediation and moderating influence, which you can actually simultaneously do, okay, in structural equation modeling. But in linear regression, okay, it will take time, no, to do so. And another, you can do correlation and linear relation, investigation also in structural equation modeling, which we already discussed about correlation, etc. So now, talking about exploratory factor analysis. So we have this what we call confirmatory factor analysis. So suppose, okay, the confirmatory factor analysis, this is actually the path analysis already, right? So that's specific example, or I mean, specific part of the interpretation, the path analysis. The other is, of course, the confirmatory factor analysis. When you do structural equation modeling, you also do confirmatory factor analysis. Like, for example, in this case, in your loading, okay, it inform you that the intelligence or the loadings for intelligence are these three. I excel in academics, I have sharp memory, I can create ideas from concepts. So in confirmatory factor analysis, when you do confirmatory factor analysis in the actual structural equation modeling, you are actually investigating uh, if this three here would really measure intelligence also. So that's what you call confirmatory factor analysis. Because later, uh, if in order to improve the model, some of these boxes here, or those measured variables, like I excel in academics, I have sharp memory, I can create ideas from concepts, some of them will be eliminated just to improve the model. Okay, some of them. So that's part of the confirmatory factor analysis. So that's uh that's how uh, that's how I should discuss to you the confirmatory factor analysis. So we were not able to discuss that one during the factor analysis introduction for factor analysis, because I just want you to focus on the exploratory factor analysis, the gathering of constructs. Okay, the variable that we can use, the constructs, the variables that we can use later, and understand if those constructs we generated have a specific relationship, okay, based on what the theory is telling. So that's it. So remember that in structural equation modeling, you have two important analyses here. First is the confirmatory factor analysis, and the other is the path analysis, which I already discussed, the mediation influence, the moderating influence, and etc. So how good is the model? So that's where we have to do the model fit and the regression weight analysis. Okay, so I already provided you a copy, okay, of my research paper entitled Truth Behind Economic Performance. There, I was able to discuss, okay, how to interpret the results, how to interpret or how to use how to interpret the model fit, the regression weight, and even the path analysis, especially the mediation effect or influence. Okay, so I think we're done with the basic introduction of or the introduction of structural equation modeling. Thank you for watching.